right, good morning. This feels a little bit like a TED Talk. So I'm very happy to have the opportunity to present this project here to you. It's been a lot of work over many years, but we're close to completing it now and very happy to present our final results. In the project, we're interested in the links between climate change, aridity, and internal migration. And we're using a novel global data set that allows us to run estimates for a large number of countries and to explore patterns of internal migration. This is joint work with Guy Abel, Maurizio Malpede, Raya Mutarak, and Marco Percocco. And Raya is also here with us today, but only virtually online. So she will be able to answer any online questions. In the project, we want to estimate the impact of drought and aridification processes on internal migration flows worldwide. And really the contribution that we try to make is that we produce a database that allows us to compare basically the effects of drought and aridity on internal migration across a large number of countries. Although we all know that environmental stress is most likely to influence internal as opposed to international migration, we actually have in many places gaps in the data when it comes to internal migration. Often we are left with like micro level data that we use in our estimates, like the project that we have done in Tanzania, for example, or we have to use proxy measures. And here we try to build on data that really observes internal mobility within countries. And beyond just allowing us to estimate overall relationships, the data also allows us to explore mechanisms and differences across contexts. So that's really the big advantage of using this comparative data set. Others have used IPUMS data before. Our approach is very closely related to a paper by Garcia et al., modeling internal migration flows in sub-Saharan Africa using census microdata. Our contribution here is that, as I said, we add further countries to the data set. So in total, we have 72 countries covered. And we bring in the environmental dimension into our estimation. So this is the database that we're using, all the countries, and what you can see within the countries are the subnational regions that represent the basis of analysis in our data. And what we use as information is answers to the questions by respondents where they live currently and where they have lived 1 or 5 years ago prior to the census. And we combine this information to calculate how many people have moved in these periods between one region A to another region B and vice versa. And we can do this for all possible region combinations in the data set, leaving us with over 140,000 bilateral migration flows over time. So quite a large sample. And you see this illustrated here for China between different regions. Here you see this with actual data for 2 of the countries that we have in the data set, Spain to the left and China to the right. And you can see the flows between the different subnational regions within these 2 countries. What is important for us is that we have the information not only at one point in time, but over time. So we really pooled all possible censuses available on IPUMS International from 1960 to today, with some countries having their first census already in the 1960s, especially in Latin America and the Caribbean. And what we do then is we combine the information about how many people have moved from one region A to another region B with changes in the environmental conditions, changes in drought and aridity in those origin regions to test if this increases outmigration or not. We use 3 different measures to capture drought and aridity index, the Palmer Drought Severity Index, and 2 versions of the standardized precipitation evapotranspiration index. And what we do is we basically run fixed effects models, so trying to estimate changes over time in migration and how they respond to changes in the environmental conditions. So we attempt to do a causal identification in our study, and we can discuss later some of the details how we do that. Moving right away into the results, and I'm only for the sake of time giving you a few snapshots of our results. So these are our baseline models where we regress the annual outmigration rate on the different aridity indicators, and what we find is a significant and sizable effect of increased aridity on migration. For the aridity index, we estimate that a 1 standard deviation increase in aridity in an origin region leads to a 6.62% increase in the outmigration rate, not percentage points, but percent. So that is still quite fundamental. We then explore in the same modeling framework differences across world regions in ecological zones and combine our model estimates with information about how drought and aridity conditions will change in the different regions. And what we find is a very distinct pattern, so that like migration responses to drought and aridity will be stronger in some areas potentially than in others. Just to mention, this is very explorative, of course, just to highlight or illustrate some of the findings from our model. So this is not kind of projections or like really strong predictions, but just to illustrate. And the greener the area, the higher our model predictions would estimate the effects to be, the migration responses. What you can see is like increased impacts in the area of the Mediterranean, in Southern Asia, parts of Southern Asia, and then in Latin America and the Caribbean. We also explore some of these regional differences more by adding in further information about the region, about the economic conditions, agricultural dependency, whether the origin and destination regions are urban or not. And what we find is primarily stronger effects. So here, the migration impacts of drought and aridity are plotted on the y-axis. And then we look at how the effects change depending on these different moderating interacting variables. And what we find is that it's particularly agriculturally dependent in rural areas where we see the strongest migration responses to drought and aridity. And then we see an interesting pattern when it comes to the wealth levels. So we see that overall, across all regions and countries, it's not the poorest regions where we see the strongest responses, but regions where we have achieved a certain wealth level. But then when we look within countries, then we see there it is often the relatively poorer regions where people are migrating out. And they are migrating tentatively towards the wealthier regions. Final results that I briefly wanted to show you, we cannot only estimate effects on overall migration from one region A to another region B, but we can also do this by different population subgroups, which is very exciting. And here we can distinguish by age, sex, and education, and we see very different patterns evolving here. So here we have distinguished, we have now the migration impacts on the x-axis, and we distinguish by less developed countries and more developed countries. And what we see is that a very distinct age pattern. We see that in the less developed context, it's more the middle age group, the working age group, that is responding more strongly to environmental stress. Whereas we see in the richer countries, in our data set, it's more older age groups where we see a stronger effect on mobility. And we can discuss later what could be potential explanation for this finding. And there's similar interesting findings for education, but I also keep these for the discussion later. And finally, just to sum up, I would just like to mention that, of course, our study also has a number of limitations. So the data is quite exciting to work with, but also comes with certain caveats. One being that we are using a very broad migration measure that may potentially miss some forms of mobility. And of course, we also don't capture any international migration. Nevertheless, we believe that more comparative evidence like this one is needed to really comprehensively understand how environmental factors influence and interact with human mobility. And with this, I'd like to stop and thank you.
Thank you, Herman.
Two very quick questions. Yeah. First, do I understand correctly that you treat in the same way migration from, say, one region of Spain to another region of Spain, and migration from one region of Spain to a region of Portugal?
No, this we don't have at all.
You don't have.
It's really completely internal migration.
Okay. It's a bit. I mean, it's interesting. Still very interesting, but it'd be excellent to have also that information.
I know of colleagues who are working with the same data, adding additionally to the internal migration, also sort of the international migration information from IPUMS, but we haven't done that here in this exercise.
Okay. And second question, so you're not dealing with net migration, but bilateral. There are two flows, one in, one out, right?
So we have done some robustness checks using net migration. So this is out migration rates. because here we saw the most consistent results, but the results also hold for net migration. But then we have sometimes cases, kind of explored that extensively, and sometimes we have cases like we have a lot of out migration, a lot of in migration, canceling each other out, and then like urban areas, for example. So we felt more comfortable with the out migration rate, but the results also hold when you look at net migration.
Thanks for this amazing work. I think you should definitely control for conditions at destination too, right? There are a few papers which shows that if you only control for shocks at origin and then add control for shock at destination, you get completely different results. So I think you should definitely control for that and see what happens.
Yeah, thanks so much for the suggestion. We also did this. I'm very happy. We have a very long supplementary material spanning over 50 pages. So we tried to do a lot of robustness checks, and we included destination. It didn't change our origin effect, and we didn't find very consistent results for destination regions, which was at the beginning a bit surprising for us. But there seems to be not so much of a kind of sort of like a factor for these migration flows.
Okay, thank you very much for such interesting results. I liked it very much. And you say that you are dealing with out migration, and the results indicate that one standard deviation of increase in aridity leads to 6.2% like that. But my question is, when you're talking about out migration shouldn't necessarily be a response for aridity. People move out for different reasons. For instance, in areas where there's access to education, when people are very much competent in the labor market, they move out in search of better opportunities because of the positive aspects of it. So the push factor, the pull factor are also there. Which one have you considered in doing your regression? If these things are dealing with push factors, that's fine, because you can easily relate with aridity, thinking that climate change is a cause for out-migration. Otherwise, if you are just considering everything, I have questions on the validity of your results.
Yeah, thank you. So primarily we are focused on the origin situation. We control for kind of destination situation and changes in the destination, but really the primary focus is on the origin areas. And we, just to mention again, in terms of the estimation, we really build on changes over time. So we try to understand if there is a change in the origin that may be completely disconnected to what's happening in destination or in any other areas. Does that lead over time to an increase in the mobility? So that's really the very fundament of our estimation. And in terms of education, because you mentioned it, we see, especially in less developed countries, we see kind of an positive education gradient in mobility. So the more educated are the ones that seem to respond more strongly to environmental stress, which can be related to sort of better prospects in destination areas. Thanks.